Hello everyone. In this video, we will see about taints and tolerations. Taints and tolerations work together to ensure that pods are not scheduled onto inappropriate nodes. One or more taints are applied to a node. This marks that the node should not accept any pods that do not tolerate the taints. Let me give you a quick visual on this. Let's say the Kubernetes cluster has 3 worker nodes, right? Assume that the node in the left has more GPU. You expect that node to accept only the GPU intense workload. What you have to do is you need to taint the node with some taint label. For now, I'll add a color to the node which represents that it is tainted. All right. So let me add red. So practically, I'll show you how it needs to be tainted later in the video, right? So once the node is tainted, add the tolerations. Okay, add the toleration in the pod that you're about to deploy. So let me add a toleration, a color to the pod which represents that it's tolerated. So this would ensure that the node would accept only the intended pod in it. All right, let's do this in the lab. So this is all about the taint and tolerations. All right, so keep in mind this is a node taint is useful only when the node needs to be reserved for special workloads. For example, in this case, a node that should only be running pods that will use the GPU. Got it? So let's do this in the lab right now. Okay, so you can run the command to taint the node, which is kubectl taint nodes. And before that, I want to show you how many nodes do I have in the cluster. So all I have is I have 2 nodes, and even the master node I have, but as of now I have just one node which is up and running, which is kube node 02. This is the master node. Even here kubelet is running. So let me taint the node kube node 02. Taint nodes kube node 02, and the label of the taint label, what I'm going to put here is instance equal to GPU. All right, so this is the taint label that I'm placing it in the node, and colon. So whatever that comes after this colon is called effect. All right, so I'm going to put no schedule. All right, no schedule is the effect, which means the node will not accept any further pods that does not have the toleration of instance equal to GPU. However, the existing pods in that node which was not tolerated will still be running. Okay, we have 2 other effects as well, one of which is no execute. So which is no execute. All right, which means the node will not accept any further pods that does not have the toleration of instance equal to GPU, and it will terminate any pods that are running in that node which does not have the toleration. And another effect is prefer no schedule. Preferred no schedule is kind of like a software, which is kind of like a software comparing to no schedule. This is prefer no schedule. If you taint the node with prefer no schedule, then it might accept pods that does not have the toleration under certain circumstances, like when no other nodes are available. So the node which are not tainted can accept the pods that are tolerated. So that's what prefer no schedule means. So let's run the command kubectl taint nodes kube node 02 instance equal to GPU, and no schedule. So once I run the command, now it says the message saying that the node is tainted. So how do you see that? Describe kubectl can describe it, and node kube node 02, and you can just pipe it with taints. That will show you if the node has the taints enabled. So yeah, now it has been added right now for kube node 02. Now the node is tainted. We need to create a pod with toleration in it. Let's create one in a declarative way. The left top corner, you see the file. This is the older file of the previous video. I'm just gonna delete that, and I'm gonna create a new one with taints and tolerations.yaml, and I'm gonna create a pod with toleration in it. Okay, it's as usual API version colon v1 and metadata colon space name. I'll just call it as test, then spec containers, container space image. I use nginx, and then name test again. I'll go with the test. Then you come with the tolerations here. All right, toleration, you have particular whatever that you have, the key and value that you have given in the node, right? Well, I mean, while tainting the node, you'll have to mention the same here. Instance is the key, and the operator equal, it's equal, hit enter, value equal to GPU. That's what it's been given. Okay, and effect is no schedule. So this is all you have to do to tolerate the pod. Now the pod has been tolerated, so I'm going to run this pod so that this pod will get deployed to the tainted node. All right. Okay, so was that a command? Yeah. As I was saying, in this case, a node that should only be running pods that will use the GPU, right? Only taint and tolerations would not help us achieve where and which pod needs to run on which node. There are chances where a pod that has toleration can be deployed in a node which is not tainted. So how do we refine it properly? So that's when we need to use a concept called affinity. We can see more about affinity in the next video. So in here, let's give it a quick check about the pod. Now, if you look at here, the pod is now running, and if you see, the pod must be running in the mostly it'll be running in the kube node 02. Yeah, as you can see. So it's because it's tainted now. So what if I don't use any taint? Then it would probably go to the master node, which I was saying. Even the master node has the kubelet running, so it would deploy to be in the master node. That's it for this video. Thank you so much for watching the video. Have a great day, guys.